Have you ever wondered how different number systems work and why they exist? Well, imagine a world where we only had 1, 2, 3 and that's it. Anything beyond would be a struggle to express. Thankfully, we've developed better ways to represent numbers, and that's where number systems come into play. A number system is essentially a way to represent numbers using symbols or digits. Think of them as different languages for numbers, each with its own unique set of symbols and rules. It's like how we communicate using different languages, each with its own vocabulary and grammar. Different cultures and disciplines throughout history have created various number systems. For example, the ancient Romans used Roman numerals, while the ancient Mesopotamians used a base 60 system. Each system was tailored to the needs and contexts of its creators. Why do we have different number systems, you ask? Well, different systems have different benefits. Some are more efficient for certain types of calculations, while others are more intuitive or easier to use in specific contexts. For instance, in the world of computing, binary and hexadecimal systems reign supreme because they align well with how computers process information. On the other hand, the decimal system, based on tens, is most common in our daily lives, probably because we have 10 fingers to count on. It's fascinating to see how these different systems have evolved and how they continue to be relevant in various fields, from mathematics to computing, and even in everyday life. The choice of a particular system often depends on the requirements of the application and the convenience of representation for a given context. So let's dive into the fascinating world of number systems and explore some of the most common ones. Starting with the decimal system, which is probably the most familiar one to most of us. This system, also known as base 10, uses 10 distinct symbols from 0 to 9. It's a universal language for numbers and is widely recognized across the globe. The beauty of the decimal system lies in its simplicity. Each digit in a number represents a multiple of a power of 10. For instance, take the number 235. In the decimal system, this number is represented as 2 times 10 raised to the power of 2, plus 3 times 10 to the power of 1, plus 5 times 10 to the power of 0. This breakdown allows us to understand the value of each digit in its respective place, making the decimal system incredibly intuitive to use. The decimal system is widely used because of its simplicity and ease of understanding. Next, we have the binary, octal, and hexadecimal systems, which are crucial in the world of computing. Let's begin with the binary system. This is a base 2 system using only 2 symbols, 0 and 1. The power of binary lies in its simplicity. For example, if we have the binary number 101, it translates to 5 in decimal. This is because it is calculated as 1 times 2 to the power of 2, plus 0 times 2 to the power of 1, plus 1 times 2 to the power of 0. Moving on to the octal system. This is a base 8 system, using the symbols 0 to 7. For instance, the octal number 36 translates to 30 in decimal. The calculation is 3 times 8 to the power of 1, plus 6 times 8 to the power of 0. Last, but certainly not least, is the hexadecimal system. This is a base 16 system, using the symbols 0 to 9, and A to F, where A is 10, B is 11 up to F, which is 15. For example, the hexadecimal number 1A3 translates to 419 in decimal. This is calculated as 1 times 16 to the power of 2, plus 10 times 16 to the power of 1, plus 3 times 16 to the power of 0. These systems may seem complex at first glance, but they are fundamental in computing. Binary is the foundation of all computing systems, representing on and off states. Octal and hexadecimal, on the other hand, provide a more compact way to represent binary numbers, making it easier for humans to read and understand. In the digital realm, these number systems are ubiquitous. They are used in programming, data storage, processing, and more. Without these systems, our digital world as we know it would simply not exist. These systems, although may seem complex, play a vital role in how our digital world operates. Now, let's look at Roman numerals, a system that dates back to ancient times, and some other unique number systems. Roman numerals, as the name suggests, originated in ancient Rome. This system uses a combination of 7 different symbols: I for 1, V for 5, X for 10, L for 50, C for 100, D for 500, and M for 1000. For instance, the number 18 is represented as acing 8 in Roman numerals, which translates to 10 plus 5 plus 1 plus 1 plus 1. Moving on, we come across the ternary system, a base 3 number system that uses only 0, 1, and 2 as symbols. An example is the number 7, represented as 21 in the ternary system. This means 2 times 3 to the power of 1 plus 1 times 3 to the power of 0. Next in line is the quaternary system, a base 4 number system. It uses 0, 1, 2, and 3 as symbols. For instance, the number 14 is represented as 32, which means 3 times 4 to the power of 1 plus 2 times 4 to the power of 0. The quinary system is a base 5 system that uses 0 to 4 as symbols. The number 23, for example, is represented as 43, which translates to 4 times 5 to the power of 1 plus 3 times 5 to the power of 0. Finally, we have the duodecimal system, a base 12 system that uses 0 to 9 and A for 10, B for 11 as symbols. This system is used in some cultures and in computing for character encoding. These number systems might appear to be relics from the past, but they're far from obsolete. Each has its unique uses and applications. Roman numerals, for instance, are still used in certain contexts like copyright dates in film credits and the names of monarchs. The duodecimal system, on the other hand, is particularly useful in computing. These systems might seem obsolete, but they still have their unique uses and applications. Lastly, we have the base 60 or hexadecimal system, which has a surprising presence in our daily lives. This system was first used in ancient Mesopotamia about 4,000 years ago. The Mesopotamians chose 60 as their base due to its divisibility. You see, 60 can be divided evenly by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. This made calculations a lot simpler in a time without calculators. Now, you might be wondering where we use this antiquated system today. Well, every time you look at a clock or watch a minute tick by, you're using the base 60 system. That's right, there are 60 seconds in a minute and 60 minutes in an hour, a direct carryover from the Mesopotamians. So, while the base 60 system may not be as widely used as the decimal or binary systems, its influence is felt each and every day. The next time you check the time, remember you're using a number system that dates back to ancient Mesopotamia. So, we've taken a whirlwind tour of different number systems, each with its own unique characteristics and applications. We delved into the decimal system, our everyday base 10 system, and explored the binary, octal, and hexadecimal systems that are pivotal in computing. We journeyed back in time to ancient Rome with Roman numerals, and even further back to ancient Mesopotamia with the base 60 system, still evident in our time measurements today. We discovered that each number system, from the ternary to the quinary, the quaternary to the duodecimal, has its unique set of symbols and base. Each system has found its niche, whether that's in computer science, ancient history, or cultural contexts. We saw how the decimal system's 10 symbols mirror our 10 fingers, making it intuitive for daily use, while the binary system's simplicity of just 2 symbols, 0 and 1, makes it ideal for digital devices. We also learnt how number systems like the octal and hexadecimal are used as a shorthand in computing, allowing for more compact representation of binary numbers. Meanwhile, Roman numerals, with their unique symbol set and subtraction principle, are still used in a variety of modern contexts, from clock faces to book chapters. Furthermore, we explored the less commonly used ternary, quaternary, quinary, and duodecimal systems, each with their unique context and applications. We even touched on the base 60 system, a remnant of ancient Mesopotamian mathematics that survives in our measurement of time. In this journey through number systems, we've seen how the choice of a particular system depends on the requirements of the application and the convenience of representation. Whether it's for ease of calculation, historical tradition, or computational efficiency, different situations call for different number systems. The world of number systems is vast and fascinating, and understanding it can open doors to a deeper understanding of mathematics, computing, and even history. Until next time, keep exploring and keep learning.